Hi friends, in this video I will talk about polar coordinate. The first step to know about it is we need to know the concept or definition of polar coordinate, and the main point is we need to know how to draw a polar coordinate. And this is first definition. Point P, this one, P, R, and theta. We know about it on class, and I want to emphasize that when R is positive and when R is negative or positive, and how to draw, how to point, how to pin it on polar coordinate. So we have a rule. If R is positive, the point lies on the terminal side of theta. If R is negative, the point lies along the right opposite the terminal side of theta. So what does that mean? First of all, we have P is 4, for example, and we should just begin with this one. We have an arrow in this one, and part of 3 here, part of 3, and it's called terminal side. So this one will be part 3. And where is P? So you see R is positive, and the point P will be on this side. So it's 4, 1, 2, 3, 4. So that's D. 4 pi 3. How about B prime minus 4 and pi 3? You see, R is negative. So it's on the opposite right of terminal side. So it will be here on the opposite of the terminal side. Pi of 3. So to identify the point quickly, first of all, you need to identify the angle first. And after that, you look at the R is positive or negative. If it is positive, it will be on the terminal side of this angle. If it is negative, it will be on the opposite side. We have another example. We have another angle, a negative angle line. 3 minus pi over 2, for example. First on, we need to identify the angle first, negative here. So it will be this way. This is terminal side. Right? So where is P? Again, we look at R. R here is positive. So it will be on the terminal side. 1, 2, 3. So let's be 3 and minus pi of 2. And where is P? minus 3 minus pi over 2. Where is it? And this one is minus pi over 2. So we look at r is negative, so it will be on the opposite side of the terminal side. So 1, 2, 3, and this one is negative 3, negative pi over 2. Another one. We have another problem like we need to find another coordinate or find another representation of the point. Find another representation of the point. So it means you have to know this formula r theta. We have another point with the same, I call it relative, and pi plus 2 pi r minus r pi or theta. Right now we plus pi into the pi right again. So for example, we have a point like 2, 5, 3. So where is P? Again, we got, oh no, 5, 3, and is positive, so it will be on the terminal side here to 5, 3. We need to find out another representation of the point, and we use this formula, so it can be 2 theta is pi over 3 plus we let n is 0 and 1 and 2 and 3 blah 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 minus 1 minus 2 things like that. So first one we let n is 1, we have 2 pi here plus pi of 3, and we got 6, 7 pi of 3. So we have another point like P2 and 7 pi of 3. But if the question asks about r is negative, we use this formula. So we need p with negative r. So it will be theta is pi over 3 plus pi plus 2 and pi. And n is 1, we have 2 pi, pi of 3. And it will be 3 pi, 10 pi of 3. So it's very fast. We do it quickly with this formula. How about another angle? Like with r is negative, we use 1 here. So pi over 3 plus pi again, 2 pi, and we got pi over 3 minus pi, and that will be, and we have this one. So the thing is, you need to remember this formula to find out another point with the same relative. And I think it's on a quiz next quiz on Wednesday. For example, we have another exercise like we have point 253. Find another point, another representation of the point in which R is positive and 2 pi is lesser than theta, lesser than 4 pi. So we come back with the formula theta plus 2 pi, and this angle here, it range of this one will be 2 pi and 4 pi. That's interval. So first of all, we let n is 0. We have theta plus 0 is theta, and that's pi 3 and 2, right? And is what? Theta here is pi 3, right? It's theta. So n is 1, we have theta plus 2 pi. Here n is 1, 2 pi. That means pi 3 plus 2 pi and 7 pi 3 and 2. And this one belongs to this interval, right? Yes. How about n is equal to 3, theta plus 2 times 3 pi is 6 pi, right? Is pi 3, so it will be 19 pi 3. It's larger than 4 pi, so you don't use this one. So just this one. Is it pi in the question, and is it another pi? No. How about find out another representation point with this point? We have is 0, so we use this formula. Theta plus pi, first one plus pi, and plus 2 and pi, and we let theta here. This one is theta. So, and we also have it for this one. This is a question. I mean 2 pi and 4 pi. Theta belongs to this one. We need to find out another theta, right? So this is another theta. And this point is the 3. We need to find another angle in which, so that this angle belongs to this interval. So first of all, n is 0 and pi 3 plus pi. It will be 4 pi 3, and it belongs to 2 pi and 4 pi. So it's good. A is 1. We have 2 pi and 3, and yes, that's okay. 3, 9, and 10 belongs to 2 pi and 4 pi. It's good. How about n is 2 plus 5 plus 2 and 4. We have 4. And it will be, yeah, it's larger than 4 pi. So we don't use it. So we have 2 points. This one here, sorry, this one here, and this one here. P of 3 or pi p negative 2 and 10 pi of 3. So again, we have this formula. 2 and pi, and we have another point with r is the same, right? And negative r right now plus pi and 2 and pi. We have another point. It's very quick. So we move to the next problem. The next problem is we need to deal with the relations between polar and rectangular coordinates. So we have a problem. X is r cosine cosine of theta and y is equal to r sine of theta x squared plus y squared is r squared. Besides that, we also have tangent of theta is y of x. So that's another problem. Example. Yeah, how about convert each rectangular equation to a polar equation? Rectangular equation. Change to polar equation. Like x plus y is 5. We know that there's a line y is equal to 5 and x. Things like that. And we change to a polar coordinate. But it's what? We call x r cosine squared again, and y is r cosine of theta. So it will be x plus y is r cosine of theta plus sine of theta, and it will be 5 in this question. And the work we have x squared minus plus y squared is r squared, right? I think we don't need to use this one because why? Because from this one we have r is equal to 5 over cosine of theta minus plus sine of theta. So we have this one, r. When we have r, we can draw a polar coordinate. How about this one? X minus 1 square plus y square is equal to 1. We need to change the rectangular equation to polar equation. Change polar equation. Yes. First thing first, let x is equal to r cosine theta, y is r sine theta, and it will be x here, right? R cosine of theta minus 1 square plus r square sine square is 1, and r square cosine square minus 2 times r cosine of theta plus 1 plus r square sine of theta square is 1. This one, cosine square plus cosine square plus sine square, and it will be 1 here, right? And here minus r cosine theta 1 is 0. So you see r square minus cosine theta is 0. R minus 2 cosine of theta is 0. And we have two things, r is 0 and r is 2 cosine of theta. So where is r is 0? Here, r is 0, right? Where is r is equal to 2 cosine theta. If we have theta is a number, but that's angle, right? Cos of power 3, 2 cosine of power 3. For example, we have r, so we find out r, so we can change to the polar equation like this one. And we choose this one. Because why? With theta is pi of 2, for example, cosine of pi of 2 is 0, and r will be 0. So in this case, we also have r is 0 here. We also have r is 0 in this case. So we only need this one. So finally, we choose the last equation. R is 2 cosine of theta. Be careful. Usually r is 0 is inside this equation. Another example, like x squared. How about From polar equation, we change to rectangular equation. It's simple. R is minus 6 cosine of theta. So we change to a thing like x, a number square plus x, a number square is 0, is 1, etc. So we come back with the reverse equation. In converse version, x is r cosine of theta and y is r sine of theta. So from here, how do you get this one? We multiply on both sides with r. We have r squared will be minus 6 r cosine of theta. And excuse me, I talk about this conversion equation a little bit with x squared and y squared is r squared. That's a formula we need to remember. So from here we have r squared, so we also have x squared minus r plus y squared is r squared, and this one will be x, so x, right? So last thing, yeah, have this one, and we change to this form. X plus 6x plus y squared is 0. So x squared plus, we can use a trivial method like 6, right? And 3, right? And 9. So it will be x plus 3, right? Square 3 here plus 9. So we need to subtract 9 plus y squared is 0. And we have x plus 3 square plus y square is 9. So that's a rectangular equation. This one, the center, this equation of a circle, right? So the center is minus 3, 0, and r is 3. If you forget about the general equation for a circle, and this is the equation of a circle, is equal to r squared. R is radius. So you see, compare this one and this one, and r is -3. This circle has a center. It has coordinates like A and B. So this is center -3 and 0, -3 and 0 square. And you see r square. So we finished from polar to rectangular. To sum up, we have three things to remember. First one is polar point. In this section, 6.3, polar point on theta plus 2 and pi. If the question asks you that you need to find r is negative, we use this formula, negative pi plus 2 and pi. And usually from 2 pi on this interval. And the second thing is from a rectangular equation, change to polar equation, and from polar equation we change to rectangular equation by another formula conversion. X r cosine of theta, y is r sine of theta, and x squared plus y squared is r squared. Usually, I think we should practice more with polar equation, and we need to change to rectangular equation. So see you.